In this question, we're told that the motion of a plunger is arrested by the resistance of a disc which moves through an oil bath. So you have a plunger which has a disc inside a closed container which is full of oil, and of course this disc creates a drag force as it's pushed through, and this has an effect on any velocity or any motion that the plunger is experiencing. So you're told the velocity of the plunger is initially v0, and though it's subject to a deceleration. And so once you're told the deceleration, you're asked to derive expressions for the velocity and the position coordinate in terms of time. So you're starting off with acceleration, you need to get to velocity, and then you need to get to displacement. So each time you're going to integrate. So to start with, you write down the equation you're going to use. A is equal to dv dt. This is equal to minus kv. So the expression you're going to integrate is dv is equal to minus kv dt. This is integrated as follows. Fairly simple. Note that the 1 over v integrates to natural log of v, and this can be simplified to give you the first expression. So the velocity as an exponential function. In order to find the displacement, you do exactly the same. This time you use the expression v is equal to dx dt. You know what v is, so again you have this expression x on the left hand side and the v dt on the right hand side. Integrating this, slightly more complex form, you this time have, because of the constant from the first one, you have a 1 minus e to the minus kt, but this gives you the analytical variation of displacement x as a function of time, given the constant initial velocity and the constant k. Now finally it asks you to find velocity as a function of displacement, and for this one you use the other expression, v dv is equal to ads or adx in this case, and again you know what a is, and it's an even more straightforward operation to substitute a as minus kv and integrate that. So here you divide through by v, so actually you're left with integration of dv and integration of dx, so it's just v minus v naught and x minus naught on this side, and the final expression is v naught minus kx.